Hello everyone, I'm going to talk to you about aspect-oriented programming and how you can add magic to your code base and remove boilerplate. So first of all, let me introduce myself. My name is Xavier Gouchet. I'm a software Android engineer at Deezer. I work on tools, mostly architecture, most of the core parts of the application. You can find me on online using my handle xgouchet, and you can find the slides for this presentation on speakerdeck.com/xgouchet. So, first of all, in introduction, what is and what is not aspect-oriented programming. So, first of all, I'd like to see a little show of hands of who has already used aspect-oriented programming in here. Good. Nice. Aspect-oriented programming is not a new programming language. It's simply a new paradigm. It's a new way of thinking, it's a new concept. And actually, it's not new, really. It's been here for about 20 years. It's not something that will replace object-oriented programming, but it's something to use with object-oriented programming. And it's not the solution to all your problems. It's just another tool that you can use in your developer toolbox, but it's not the magical solution to all your problems. What it is a tool. It's a tool that can enhance modularity and separate cross-cutting concerns. I'll come back later on what I mean with cross-cutting concerns. It's a tool that will help you focus on business logic, which is what you should focus on, and it will reduce the noise in your source code. So, what's the basic idea of aspect-oriented programming? Let's look at a little bit of an example code. It's just a simple method like that with some logging, with some transactions, try catch, so we can avoid crashing the application, and the actual business logic that this method do. All the rest is just utility code that goes around. The logs is just for the developer. The transaction is to make sure that things can run smoothly on concurrent thread, and the try catch is just to avoid crashing. So it's quite a lot of code for just one business logic line. With aspect-oriented programming, we can reduce that to just this method, which means that the logging is just an annotation, and the try-catch clause and the transaction is also in a single annotation. So, what do I mean with cross-cutting concerns? We've seen a few examples here: logging, security, transactions. There are lots and lots of more cross-cutting concerns. Basically, it means a little bit of code that appears everywhere in your code base. So everywhere in your code you have loggings, you have cache, you have notification, multi-threading, serialization, validation of inputs, and lots of other stuff. And basically it's all the boilerplate code that you write again and again and again everywhere in your code. So aspect-oriented programming is a tool that can help reduce this boilerplate code. So let's just take a step back, look a bit at what is some CSS and HTML example. In CSS, I hope everyone is a little bit familiar with the syntax, but basically you can add some attributes, modify some attributes on HTML elements based on selectors. So for example, you can have selectors on a class, on IDs, you can have selectors on states of elements. So for example, a link which is hovered by the mouse, or even some attributes which are already on elements. So for example, the attribute type on an input element. And you can change the appearance or behavior of these elements. So we define three different items in this. It's around the selectors, which are the rules, the patterns that help us know what should be modified. The elements, which are the actual position in the code, which are going to be modified. And the attributes, which we are going to modify. So if you understand the way to think with CSS, you already understand and you already use aspect-oriented programming, because it's just that. In aspect-oriented programming, we use pointcuts, which are the selectors of CSS. It's just rules and patterns to know what to modify. The join points, it's just a name to know what position in the code can be modified, and the advice is the behavior that we're going to add. So we are going to write an aspect using AspectChain, which is one of the tools that can be used to perform aspect-oriented programming. What I like about it is that, first of all, it's bytecode weaving, which means that bytecode is injected inside the class files that is created by JVC at compile time. So there is no, or almost no, overhead in the runtime. And also, it can use simply annotation, and you can create your code directly inside Java classes. So let's look at a bit of a world. Here we are going to define an interface. So I don't put all that you should add, like the retention, the targets, but it's basically just an annotation, that we're going to use on a method. And what this annotation says is that I want to log when I get inside, when I run this method. And how we are going to write the aspects, we just create a new class, which I call tracelog aspect, annotate it with the aspect annotation, and then I create a pointcut. So a pointcut, like I said earlier, is the pattern to know where to modify the code, like the selectors in CSS. Here the pattern is I want to find the execution of a method which is annotated with tracelog, and there is no other pattern about the method itself. So the wildcards here just say it's a method with any name, any return type, any parameter. And then I create my advice itself. So first of all, I use the before annotation, so which means the advice will be run before the method itself will be run. And in the advice, I get a join point object which knows the method, its arguments, and where in the code we are. So I can just use a log that will print out the signature of the method I'm running. So basically, it's just that. It's just when I run this when I run this piece of code, without adding anything else, it will print out in the logcat every time I run into the method. So this example, you'll find it everywhere when you want to start to learn aspect-oriented programming, but it's not very useful. So we are going to look at some more concrete examples of what you can do with aspect-oriented programming. The first thing is that you can use aspects to run performance monitoring. So basically, you have here the around advice. So instead of running before the method, we are going to run around it. So when we get it there, we get a proceeding join point. And then on this join point, we can use the join point like proceed that will actually run the method that has been weaved. And so what I do is just get the time before I run it, get the time after I run it, and for now just use a log to know how much time I spent inside the method. So it can be useful to know, to add some performance monitoring on anything. We can add also memorization. So memorization is just basically adding cache to method in themselves. So basically we always use an annotation, and here we just keep a cache. So when I get, when I run, again I use the around annotation. When I want to run a method which is annotated, I just get a look if I have already a cached value of this method with these parameters, and if I don't, I actually run the method. So this is very useful if you want to run a method based on input parameters, which can be heavy, which have we can have a load of computation time, you can just cache the result of the method just using the aspects. Then we can also use aspects to perform database transaction. So if you use SQLite databases in your application, basically it's something you run into, you have always the same boilerplate code. So again, we use the around annotation to go around the running of the actual SQLite transaction we want to do. And we do automatically, we begin the transaction successful and transaction and the try catch block to make sure that nothing crashes for the user. So here is just another thing that is very useful with aspect-oriented programming with AspectChain is that inside my around annotation, I can say, okay, I want to capture the argument that is passed to the method I'm weaving against. So I say I want to find a method that has a database as input, and that way I can use it inside my advice to actually do the transaction based on the database that is sent to the method. And you can also use that for validation. So for example, there is validation annotation that uses a regex to validate user input to make sure it's correct based on some rules. And for example, here when we want to set the username, we want it to be at least 6 characters long. And for the password, we have some maybe more complicated regex. When we create the annotation, the aspects, here we can so first capture the input that is set on the method, but also can capture the annotation on the method itself. So here, when we get inside the method, we get the input and the annotation, which means that we can directly get the regex parameter in the annotation and use it inside our advice. And here, in my example, I just use a standard pattern matcher, and if the input doesn't match, I just throw in an exception. So one of the questions you might ask when I do that is, what is the stack trace going to look like? It's basically very, very simple here. We can see that, so I have what gets into my actual method. Here, the set password is a method which has been annotated, and here my advice is right there. So there is nothing in between the method that has been weaved and the actual advice. And that's because when the compiler creates my advice, it's injected in the bytecode, so there is no proxy, there is no wrapper around the methods. Here, another example. So we have we create an undoable action with undo and redo method, and we are going to automatically create some field action, undoable action. Basically, we are going to use reflection to know when a field is changed on an object, on the instance of an object, and create automatically the action to undo this modification and probably have something for the users to undo and redo automatically. So here, I just capture the target object, the instance of the object which is going to be modified, the reflection field, the old and the new value, and the implementation of the undo and redo is quite straightforward. And the aspect itself lets me capture within, for example, within any classes inside a package. I can then use the before annotation to run the advice before setting a new value at any public field inside my model class, and capture the new value and the target of the set method. And just like this, I can create my new field action and pass it to the undo manager. Then gatekeeping is also very easy to do. So if, for example, you have parts of your application that you want only to be seen for, let's say, beta users or developers, you can create. So here I use enums because it's easier to read, but you can use in-depth, of course. You have this gatekeep annotation that uses an array of rows. And the way you use it is inside your code. You just say, okay, this method is gatekeeped, so I can only use it if I'm a dev or a beta user, and this one can only be used by dev users. And the aspect, again, just captures the annotation, and using the around annotation advice, I can condition the execution of the method if the actual user has the permission that I want. So the around advice is very easy when you want a method to be run only if some conditions are met. And here is the most obvious example. Then we can automatically create multi-threading. So we all know I hope you all know there is a UI thread annotation that lets you specify that some method must be run on the UI thread, but it's just some information for the compiler to know beforehand that it should run the UI thread. It's not actually making the method run on the UI thread. Using aspect-oriented programming, you can do something like that. So we say we have an annotation named run on UI thread here. The UI thread aspect here will have a handler that gates the main looper. And what it does is, so I use again the around advice. What I do is, if I'm already on the main looper, I just call jpeg.proceed and the method just runs like it should be. And if I'm not, I just post it inside a runnable to my handler. So whenever you use the add run on UI thread annotation on any method, if you're on the UI thread, it runs immediately. If it's not, then it is posted on the UI thread. So you don't have to do your get activity dot run on UI thread or stuff like that. Just an annotation makes sure that your code is actually inside UI thread. So there are lots of more examples, and I don't have the time to go through all of them. So you can automate read write for fail requests when you work with the server. You can automatically handle read write logs when writing concurrent code. You can basically remove any boilerplate that you have. But it can do also more than just advices. For instance, here you can declare the precedence of aspects. So if you have multiple aspects, you can just say, okay, my aspects of some priority for, aspects can be prioritized. So for example, if I say that this aspect is of higher importance, and this one, and this one, and this one, and when you have multiple aspects that can run on the same method, this helps you know in which order they are going to be run. Then you can also have compile time checks. So the greatness of aspect-oriented programming is that you can find and target specific positions inside the code using the pointcuts. And in this example, I use pointcuts to find methods that are running inside the core package. So any method that is declared in the class within com.example.core. And I can also detect call to methods which are in the UI package. And basically, when you combine both, you can say, okay, I want any code inside the core package that calls a method which is inside the UI package, and say that it's not supposed to be. So for example, if you want separation of concern, you just combine those, and you use the declare error, and then automatically at compile time, you will get the error, the little red wiggly lines where this pointcut is valid. And you also have a declare warning if you have just warnings. But basically, you can find and target specific patterns and make them errors. For instance, also, if you know, if you want to avoid calling, actually creating a new fragment, but having the method, a static method called on the fragment to send the arguments or whatever, it can be done. So this is very useful when you want to make sure that developers follow some guidelines which cannot be enforced otherwise. Finally, we can make makesense. So basically the idea with makesense is to provide an implementation to any class at compile time. So you don't have to make the implementation yourself and just add your implementation just based on some pointcuts. So for instance, this is the named interface, so something that has a name, and a basic name implementation. So it just gets the toString of any name which is provided to him. And the aspect, so sorry for formatting, the aspect just, so in my aspect I declare a mixing which make any class inside my com.example a named object. And so I can just use a cast inside my code and say, okay, I want to use it as an iname object and get the name. So of course the name is a very simple example, but then again, scale is the limit. So here are some general advices about aspect-oriented programming. And things to remember, basically, just before, is that aspect-oriented programming should be used for cross-cutting concerns. Basically, it's no use, so it's very fun to use and it's very interesting, but do not use aspect-oriented programming when just object-oriented programming could do the work. So basically, if just creating a super abstract class makes the deal, use it. But if you have really cross-cutting concerns, so boilerplate code that will go around and around everywhere in your code, then you can use aspect-oriented programming. Then things to remember, by default, any aspect that you write, any class that is annotated with the aspect annotation is a singleton. But you can use some annotation to say, I don't want it to be a singleton, I want to have one instance per pointcut. When you create aspect-oriented programming with AspectChain, it's classes. So you have inheritance, you have abstracts, generics, inner classes, everything that goes for regular Java classes. So you can create generic aspects and then implementation of those generic aspects. You can, of course, have different aspects inside different flavor directories. So, of course, it's standard Java code. And the basic idea is that aspect-oriented programming is real programming. So, of course, you can do very simple stuff, but you can do very, very advanced stuff, very complex stuff. Which brings me to the other part, that it's a kind of magic. It's what I advertised, but when you use it daily, it feels like a kind of magic. And so here's some example of magic. Is an aspect that prevents the appearance of null pointer exceptions. Basically what it does is, within any class inside the com.example model package, it will replace the arguments of a join point by the empty string if the argument is null. The problem is if your method doesn't use string object but some other class or primitive, this will crash at runtime. So basically you can prevent those kind of magic using annotation. It's what I did in almost all my slides. It's what I do when I use aspect-oriented programming. I preferably always use annotation. You can find a method to with using just the package name or the name But I prefer to use annotation because then what is done is explicit. Just a couple of errors to avoid to the Pokemon. Basically, you gotta catch them all. If your point cut is too wide, you just try to be as precise as possible. Also, try to avoid having a point cut which match very unrelated join points. One of the biggest mistake you can make is the exception. Basically, aspects are Java code too, so the method inside an aspect can be found by the point cut. So you can have an advice running on itself, and then you can have a stack trace exception. And avoid also the aspect class, which does too many different things. You can have one aspect class per thing you want to do. And that's all for me today. Thank you for listening. If you have any questions, please feel free to come to me. I think we have 2 minutes for that.